Okay, so we want to find the tangent vector t, the normal vector n, binomial vector b, and the curvature k. Right? And we're given these two vectors. So it's really going to be, I wrote out all the formulas, right? And there is different variations for these formulas, but these are the easiest because you're always usually given RT, and then you just go and find them, right? So it's really just taking all the derivatives and then just applying those derivatives in the formula. So let's do A in green, and let's find R prime of t. So R prime of t, and then I'm going to change the notation. I don't like IJK notation, I like bracket notation. So we take the time derivative of this top part. We're going to get 3 cosine t, negative 3 sine t, and 4. Okay, find R double prime of t. The reason why I'm finding R double prime of t is because, as you can see, you kind of have to do it anyway. Okay, R double prime of t, what do we see? It's going to become negative 3 sine t, negative 3 cosine t, 0. Okay, now let's find this. But before we do that, let's find R prime of t's norm. So then we go take the norm of that. What do we get? We get 9 cosine squared t. And yes, guys, I'm going to do this in my head because at this point I've went over many parts in the video, and we all know how to take norms of these vectors. So try to save some time by doing this in my head. Plus 9 sine squared t plus 16. And then we see that to be 9 plus 16 because these are cosine and sine squared. 9 plus 16 is 25. Square root of 25 is 5. Okay, so we found the norm of R prime of t, and we found R prime of t. So we know that t prime of t is. We know that t is this, right? This guy divided by this. So otherwise, you can just write 1/5, 3 cosine t, negative 3 sine t, and 4. There you go. That's one of our answers. Okay, well now we need to take t prime of t, right, for this formula. So t prime of t is equal to 1/5. You keep the fifth on the outside, just constant, and then now you take this derivative here, negative 3. It's basically this thing right here, negative 3. It's not basically, it is this thing here. Negative 3 cosine t, and 0. And let's take the norm of this guy. Take the norm of this guy. Remember, you're taking the norm of this vector, but this is a factored out. Like, this is a factored out constant coefficient, right? So you could essentially just leave it out there again for the norm and just have it as 1/5 out here, and then the norm, right? And just the regular, but as you guys can see, we're going to have 9 sine squared t, and then a 9 cosine squared t when we square and everything, right? And then 9 cosine squared plus 9 sine squared is just 9, right? Because the property, so then we just get 3/5. So now when we write out what n is, which is what we wanted all along, we could see that there's this guy divided by this guy. And remember, there's 3/5 here, right? If you put this in here. And there's a 3/5 here. So what that means is the 3/5 cancel out, and then this vector is just going to become negative sine t, negative, that was the ugliest writing ever, right? Sine t, cosine t, 0. There we go. Okay. Okay, for this next part, we want to find the binomial vector, so b, and then we set up this cross product, right? So t, this is t, and this is n. So 3/5 cosine t, negative 3/5 sine t, and 4/5. That's t. Okay. Then what do we see? And then we want n here, so we go negative sine t, negative cosine t, 0. We take that cross product, and we'll see that, let's write it out this way. It is we'll write this as a column vector. 0, then negative 4 over 5. Negative 4 over 5 cosine t. We'll go negative here. And what we get, 0, 5, and then look at that, negative, negative, so just 4 over 5 sine t. And this last one, this times this, which, look, there's a cosine times a cosine and a sine times a sine, negative, negative, positive, negative, but there's also a negative in here, right? So it goes, this is a negative, and then this will be a positive, but then times another negative. What does that mean? Well, it means that everything here, the cosines are going to be squared, the sines are going to be squared, and it's going to be negative. Then you can factor out the negative, right? So now we have so positive 3/5 cosine squared plus 3/5 sine squared, which, what is that? That is just negative 3 over 5. Okay, well that's your binomial vector b, and if you want to write it as the other vectors, how I've been doing it, you can write it like this, 4 over 5 cosine t, negative 4 over 5 sine t, and negative 3 over 5. It's the same thing. I just wrote horizontally there just to keep it consistent. Okay, here's the next part. We're going to have to find the curvature here. So k. Okay, so look at this. We're going to use this formula because this one's nicer than this one. Although sometimes this one is nicer, but we'll use this one. Okay, so literally it's 3/5 divided by, where's r prime t storm? 3/5 divided by 5. What's 3 divided by 5 divided by 5? That's 3 over 25. So there we go. That took 4 seconds. So you found everything we needed for part A. Now let's do it for part B. Okay, for part B we're going to be doing it in black. So let's find the time derivative for r of t. What do we get? We get negative sine t plus, and then apply this product rule here, which should be sine t plus t cosine t. And yes, the sines can go, oh, look at that. And then sine t, that's cosine t, then minus, and then we'll see that that becomes t cosine t, t cosine t, yep. I'm focusing on this part right now, I'm trying to take that derivative. Then plus, 1 second, I'm going to do a little bit of a trick here. I'm sorry, I actually have to do this right here. Negative t cosine t. What is that derivative? Well, it turns into negative. Now we can do it. Sorry, my mental space. I need to do this personally. Cosine t plus t negative sine t. Which, let's write it as t sine t minus cosine t. There we go. Sorry. Very important for you to know how to write these. Okay, so then we would have a cosine t. This thing right here is just that part. That's just its derivative. I just needed to take the extra time to write it out nicely for myself. I'll erase all this junk work in a second. Okay. So there we go. And yes, those guys cancel. No surprise. And then we'll take the derivative of 3, which is just 0. And I need to take a piss. Okay, there we go. Now I'll just simplify this a little bit nicer and just write it out as t cosine t, t sine t, and 0. There we go. Okay, now we want to find the norm of this. So the norm of r prime of t. Well, that's going to be t squared cosine squared t plus t squared sine squared t. And yes, this just works out to t. My t's are starting to look kind of ugly. Okay. Well, if we know what our prime of t is and the norm of our prime of t is, then we found this guy. So we know that this guy is just equal to this guy divided by this guy, which just turns into what? Cosine t sine t 0. There we go. And yes, I will now start making more space. Okay, now that we found this guy, we want to find this guy. So we should take this guy's derivative. So t prime. Right, what does that turn into? Well, that turns into negative sine t and cosine t 0. And then we take its norm. So t prime's norm, what is that equal to? Sine squared plus cosine squared, right? Square rooted, it's 1. So in other words, the normal vector is just actually equal to the tangent vector in this case, which is kind of funny. That is a coincidence. That's not always going to happen, so don't rely on that. Just a very lucky coincidence. Okay, let's find the binomial vector. Right? Okay, so what you do is you put t prime in, you just put t in here, which is cosine t, sine t 0, remember, this guy. Then you put this guy in here, so negative sine t, cosine t 0. I have a good feeling that this is going to work out to something really nice. 0, 0. So let's do the vector setup again. 0, 0, 0, 0. Please, please just be 1. Oh, look at that, it's 1. It's literally just 1. Or you could write it as k hat. That's your binomial vector. Just works out to that. Okay. So what's the curvature? The curvature k. We use this formula. So the norm of the derivative of t prime is just 1. And then the norm of r prime of t is just t, so then we just get 1 over t. Yes, there we go. That's all you have to do for these. It's just a lot of derivatives, but just be careful. Don't let your derivatives in your algebra get out of hand. And always write down these formulas first, because you need to use them, and it'll help you guide yourself along the way. Right?